Hi, this is Mrs. Jackson, and this is the second part of Section 4, Chapter 4 on the unit circle. And in this quick video, we're going to look at the unit circle, going all around it, and specifically look at angles that are multiples of 30 and 60 degrees. So in other words, we're really focusing in on the special right triangle, 30, 60, 90. All right, so let's get started. I'm going to label the angles kind of on these lines here, even though we know that the angles are in here. If I start to put these angles all in here, it's going to get messy. So first thing, I'm going to go around the circle and I'm going to start labeling these angles, starting at the positive x-axis here, and we're going, of course, counterclockwise, standard position of an angle. So this first one is going to be 30 degrees, and then 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210, 240, 270, 300, 330, and all the way around. We started here at 0, which is also 360. They're in the same place. Okay, so those are our angles in degrees. And we're now going to write those angles in radians. Remember, 360 degrees all around the outside of the circle is 2 pi radians. That's why we would multiply 2 pi by the radius to get that outside length of the circumference. And therefore, half of the circle, 180 degrees, is 1 pi. So I'm going to take 1 pi and I'm going to divide it into 6 pieces, or 6. And I'm just going to start at my 0, and I'm going to go all the way around the circle. So I'm going to start here with 0 pi radians. And here I've got pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. I'm just counting my fractions. 5 pi over 6, 6 pi over 6. Might as well keep going. 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and all the way around the horn is 12 pi over 6. And so you could see some of these radian angles can be simplified and some not. So starting here in quadrant 1, pi over 6 is pi over 6. Can't simplify that. 2 pi over 6 simplified is pi over 3. 3 pi over 6 simplified is pi over 2. 90 degrees is pi over 2 radians. 4 pi over 6 is 2 pi over 3. And 5 pi over 6 can't be simplified. 6 pi over 6, of course, is just pi. 7 pi over 6 can't be simplified. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. 11 pi over 6 cannot be simplified. And of course, 12 pi over 6 is 2 pi. Okay, so I'm just going to erase the unsimplified angles just to clean up my diagram here. Now we're going to take a look at the special right triangle 30, 60, 90, and we're going to use these properties to find the x and y coordinates all the way around that circle for these special angles 30, 60, and all the multiples of 30 and 60. So remember this diagram. A 30, 60, 90 is basically half of an equilateral triangle. Actually, I'm going to go ahead and draw that. So an equilateral triangle has 3 equal sides. So if this is an altitude or the height drawn here, let me highlight this, in the middle of that equilateral triangle, and this is y, then this would be y over here. So all 3 sides are going to be 2y. Consequently, this hypotenuse here is going to be twice the length of this side here. And so if our hypotenuse up in that unit circle is 1, which that's the definition of a unit circle, so this equals 1, then this little piece right here is going to be half of that, or 1/2. And if we use the Pythagorean theorem at that point, then we will see that this side length here, what we call the medium side is opposite that medium angle. That's going to be this piece here times the square root of 3, and so this length here is going to be the square root of 3 times 1/2, or square root of 3 over 2. So if we look at this here, then the short side, the short is opposite the 30 degrees. The shortest side is going to be opposite the smallest angle. That's going to equal 1/2. The medium side, opposite the 60 degrees, which is the medium angle, is going to be square root of 3 over 2. And then the hypotenuse, of course, is 1 on the unit circle. So we're going to use these values all around this circle above, and we're going to adjust their signs depending on what quadrant we're in. Okay, so remember that the x-coordinate is the cosine of the angle, and the y-coordinate is the sine of the angle. So if we just summarize here, we could say the cosine of 30 degrees is going to be that adjacent side. So that's square root of 3 over 2. And this is exact rather than approximating. The sine of 30 degrees, that's going to be the opposite. So that's going to be 1/2. And the cosine of 60 degrees is going to equal the sine of 30. So the cosine to the 60 adjacent to that 60 is 1/2. And the sine of 60 is going to equal the cosine of 30. Because from the 60 degrees, the opposite is the square root of 2. So we're going to use these values and adjust the sign above. All right, so let's do that. Okay, so we're going to start to fill in the x and y values for every point with these special angles. So starting here on the positive x-axis, this is 0 radians or 2 pi radians, and the x-coordinate there on the unit circle is just going to be 1, and the y-coordinate is going to be 0. Okay, so for 30 degrees, the x-coordinate is going to be square root of 3 over 2, and the opposite, the y-coordinate, the sine, is going to be 1/2. Across the 60 degrees, cosine of 60 degrees is 1/2, and the sine of 60 degrees is square root of 3 over 2. Up here at 90 degrees, our x-coordinate is 0, and our y-coordinate is 1. And now when we move into quadrant 2 here, this 120 degrees, its reference angle is going to be 60. The reference angle is the acute angle to the closest x-axis. And so the values here for 120 degrees are going to be exactly the values for 60, but we have to adjust the signs. And so you can see the symmetry that's going to happen here. The x-coordinate, of course, is going to have to be negative, and the y stays the same. Likewise, 150 degrees, its reference angle is 30 degrees. And so this 30 degrees and this 30 degrees are going to result in the same values, but we just adjust the signs. So we'll have negative square root of 3 over 2 for the x value, and positive 1/2 for the y value. And for 180 degrees or pi radians, our x value is -1, and our y value is 0. For 210 degrees, that's the same thing as 30 degrees. So these are going to be identical. We just need to adjust the signs, and in quadrant 3, both x and y are negative. So we'll have negative square root of 3 over 2 and negative 1/2. And 4 pi over 3 radians, or 240 degrees, its reference angle would be 60. So we're going to adjust the signs and use the same values as a 60-degree angle. So they'll both be negative in quadrant 3. At 270 degrees, or 3 pi over 2 radians, our x value is 0 and our y value is -1. For 300 degrees, its reference angle is 60 degrees, so it's going to have the same value as 60, but we're going to adjust the sign. So this time in quadrant 4, the y coordinate is negative, and 330 degrees, its reference angle is 30 degrees, and so we're just going to adjust the signs. And there you have it. In every single one of these cases, the x-coordinate is the cosine of the angle, and the y-coordinate is the sine of the angle. And all of these values are exact. So when we have special angles, such as multiples of 30 and 60, as well as 45, and when we represent the x and y coordinates of special angles, 30, 60, their multiples, as well as 45 and its multiples, we do not convert these irrational numbers into decimal approximations. So we use the exact values. Okay, so what type of problems might you see using the unit circle? I apologize for not giving a lot of room, so I would encourage to write small. So maybe problem number 1, what is the sine of 270 degrees? Using the unit circle, we look for the 270 degrees right here, and the sine, of course, is the y-coordinate, and so the sine of 270 degrees is -1. Maybe what is the sine of 7 pi over 6 radians? You look for 7 pi over 6 radians on the unit circle, and we find it right here. It's the same thing as 210 degrees. The sine is the y-coordinate, so the sine of 7 pi over 6 radians is -1/2. Number 3, let's say find the cosine of 960 degrees. Well, 960 degrees is not on the unit circle, so we're going to have to find its reference angle. So all the way around, once around the circle is 360, twice is 720. So if we subtract 720 from 960, we'll find that we're actually looking for the cosine of 240. So they're going to be equal to each other. And the cosine is the x coordinate, and if we go to 240 degrees, then we are looking at -1/2. And let's try that with some radians. So if I said find the cosine of 8 pi over 3 radians, what does that equal? Well, if we look around the circle, we don't have 8 pi over 3 radians. We know that once around is 2 pi radians, so you might want to look at this as a mixed fraction. So we'll say cosine. This is the same thing as 2 2/3 pi. So 2 pi of that is just going around the circle. So we have 2 pi over 3 left. 2 pi over 3 is right here. It's the same thing as 120 degrees. Cosine is the x coordinate, so we're looking for -1/2. And then we can also look at these as inverse operations. So for example, if I said the sine of theta equals 1/2, and I ask you, what is theta then? Well, the sine is the y-coordinate, so you're going to look around the circle for anywhere where the y-coordinate is +1/2, and you're going to have two answers. So we've got 30 degrees here, as well as 150 degrees. So if I wanted you to give me the answer in degrees, you would say 30 and 150. Or if I said give me the answer in radians, you would say pi over 6 and 5 pi over 6. So this video introduces the special right triangle 30, 60, 90 and how we use that to find sine and cosines of any multiples of 30 and 60 using the unit circle. Thanks for listening.